This is reading week 10 for Physics 2212. We first talked about Faraday's law, which is a law that can help predict how a magnetic field and a circuit will behave and how they will produce an EMF. One of the most interesting things that I learned from this video was how prevalent this law is in our daily lives. Small tasks like charging a cell phone or swiping a credit card both rely on Faraday's law. We then talked about the falling magnet for which we had to find the magnetic flux, and this magnetic flux changes in time because the magnetic field will change in time as the magnet falls. This time-dependent equation is highlighted in yellow. Faraday's law then tells us that the E field will circle around that wire. The direction of the E field can be found by pointing your thumb in the direction of negative dB over dt and curling your fingers around the electric field. In the next video, we saw that the magnitude of the integral of E times dL was the EMF. This meant that the EMF could be the source of energy in a circuit. Bringing all of these ideas together with a conductor in the form of a wire, we can see how the current, electric field, and magnetic field all work in this system. Something that I already knew was that the conservation of energy would have to apply here, but what I didn't know was that the energy came from the gravitational potential energy of the falling magnet. Another topic that was new to me was Lenz's law, which states that the magnetic field from the induced current opposes the change in flux. I found this topic to be pretty confusing, so I watched a physics ninja video, which was really helpful because it showed the different cases and how to find the direction of the induced current in each of those cases. In the last video, they introduced us to how to find the force on this falling magnet from the loop. And in order to do that, we first talked about the magnetic dipole moments of both the magnet and the conductor. Mu sub m will point from the south to the north pole on the bar magnet, and the mu loop will point up towards the magnet. We would then use these to find the force of the magnetic field from the wire loop. We went through a series of equations, first finding the electric field of the magnet, and then relating that to the EMF, and eventually F loop, which points downwards, and this tells us that F loop on M will point upwards. I had a bit of trouble connecting this topic to my major of environmental engineering, but went back to some of the applications of Faraday's law. I wondered if there was a way that we could sort of learn from this law, or maybe manipulate how it's used to cut down on energy usage, as it is used in many different ways, like in electrical generators and motors and transformers, which can have pretty negative impacts on the environment.